It's a sound. There could be a popping sound, there could be discrepantation, there could be various sounds. You have to hear it very keenly and then accordingly identify. Now,
Even temperature change.
temperature is sense of touch. Usually we don't use the temperature because there's a chance of you getting burnt. So what we do is because you're holding a test tube holder, so the temperature part of it is not there. But if you see fumes and you know that the contents are hot, then automatically you'll come to that conclusion. Okay?
What made to touch?
Pardon me?
Even made to touch. Those are so
Yeah, sometimes.
Very, I wouldn't do that because sometimes when you're pouring the liquid in the test tube, the liquid may flow out and trickle down the side of the test tube. And if there is acid and you touch it, then you know what's going to happen. So I, as an experienced teacher, would not allow it. But I would ask you to keep your eyes open, keep your nose wide open, keep your ears wide open, and your big mouth shut. That would be my instructions in the laboratory and in the classroom as well. Now, let's go to the very first one. How would you identify that?
But like today we were like having an experiment for H2SO4 with
H2SO4. What were you doing
yeah,
with H2SO4?
H2SO4 or
One at a time. Let us say, then I'll give you a chance to say. Yeah.
yeah, so we
This is
added
going to be an interactive class, okay? Nothing one, no monologue. Not interactive, okay? Come on, yeah.
so I added NaCl. So
Do what?
Liquid solid.
NaCl no magnesium. Oh yeah, okay. Yeah, so we added magnesium to H2SO4 and I was like shaking it with my hand. with the thumb, not like that, like gently. Yeah, and the acid actually touched my thumb, but like nothing really much happened. Nothing happened.
Fortunately, that means that acid was likely dilute. It was
Diluted.
It was dilute, okay? But always that. But sometimes if you are if the fume has not done it properly, the teacher has done it and prepared the solution, okay, you can rely on what the teacher has done. But if the fume has made a mistake and added slight concentration, then you will have the consequences. You will face the consequences. First of all, when you are holding the test tube, never hold it straight and shake it. It has to be done at an angle. At an angle. Again, away from the face, and also away from your. See, you are standing one close. I tell you, an incident what happened in my laboratory in the 11th standard. So what I'm saying is, you have your, I don't know how your laboratory is arranged, but you have your two students standing here. There's a basin and a tap in between, and two students on the other side. So when you are doing a particular test, you're supposed to hold the test tube, and very gently you have to move the test tube with the contents in it over the flame. If you hold it just one place, contents are usually bad conductors of heat. And if you hold it like that and you keep on talking, etc., ye ho gaya, wo ho gaya, so that will burst out. It will just come out and it may damage somebody else. Okay, but if you keep on continuously doing it very gently, and very gently you are stirring the contents and the heat is moving evenly, like what you do on a stove. If you just keep something on the stove there, only the water part will get burnt. But if you keep on continuously stirring, the entire heat is evenly distributed to the entire contents of that container. Now what happened is, we were doing a particular experiment called the brown ring test. We had to use sulfuric acid as well as nitric acid. And I told them and I warned them that very gently you have to heat it. There's the content because both of them are strong acids. It was temperature. They're strong acids. So, and then they said, yes, miss, I explained to them, I showed them how to do it, and I sat down on my table and I was taking their attendance. Roll number so and so, they would come, they would say, President, and give me the journal, and I was correcting the journal. At that time, suddenly I heard a loud scream. Somebody screamed very loudly. And I realized that one girl had gone and, the opposite girl, she was talking and she did not bother to see. The test tube was facing the opposite girl and it came straight on her eye. And it's a girl. I'm not saying that, boys should be damaged and girls should not be damaged. I didn't say that. But it was a girl, a very cute looking girl. And my God, and I panicked. I just panicked because there were 32 in the laboratory, and I just do not know whether I should take this girl and give her a first aid and leave the remaining in the laboratory with the burners on, the acids on. So the first thing I did is put up the burners, put everything up, get out of the laboratory. Get out because they were all naughty children, fathering else. And then immediately I ran down and I poured a very dilute base on her face. That was acid. So I just put base, so I put sodium carbonate. But that is also chemical, no? And the skin was all pink and it was blistering. Then I ran down to the infirmary and fortunately they had sapromycin. You know what sapromycin ointment is? And it was in the fridge. So that I applied on her face and it gave her a cooling effect. But I had to make sure that every part of her skin was covered up with that sapromycin ointment because the skin is open and she could get tetanus infected. Because the tetanus germs are there in the air. You cut your skin is protecting it. But if you cut your skin, immediately they say take an anti-tetanus injection because the germs are there in the atmosphere. And I put her in my car and took her to Dr. Popkar. I know you know about Dr. Popkar, who's in Sector 7. I took her there and gave her her first aid. I gave her the first aid. Of course, I didn't have any cash with me, that much of cash in there because I came to teach. I'm not to carry heavy cash to attend to medical problems. Fortunately, he understood, Dr. Popkar understood, and then he called her father and she was taken home. But sometimes when I see her, then after that, I joined ICSE college. I left father because it's a private institution. And ICSE college is a government institution. I joined there, then this girl finished up her graduation and then she got married and she got twins, one daughter, and after that she got twin daughters, got together 3 children. And when those twins were about 8 months old, she lost her husband. He had a massive heart attack. It was so sad. The girl stays here only in Sector 17. It was sad. Mother of 3 daughters. Eldest girl was there. These babies were 8 months old, and she lost her husband. It was very sad, very sad. And the scar, each time I used to see her, it reminded me of that baby because you could see the scars on her skin. One error. Fortunately, her eye was not destroyed. The eye was not destroyed. This is what I'm saying. You have to be very, very careful when you are doing your experiment. It's not a place for you to gossip. It's not a place for you to play the fool. It's a place for you to be very, very cautious. Because you're dealing with chemicals, you're dealing with very strong chemicals, and you're dealing with fire. And you're dealing with fire. This is, and I can't keep on telling you, please keep toothpaste in your bag because sometimes toothpaste, when you apply, it cools. That burning is so bad because it's acid burning. And no matter how much of water you put, water is not going to be neutralized. You've got to have the presence of mind to use a base. That's also acid, that's also a chemical. It may suit the acid. You're using the base to neutralize the acid, but it can cause skin infection. So they're using chemicals, not using any ointment. Okay? And you can't carry a first aid kit with you all the time, but you can be careful. Carry cautiousness with you everywhere you go. Are you understanding what I'm saying? You cannot carry your first aid kit with you, but you can carry caution with you. This is clear because of your error, somebody else can suffer. Or because of somebody else's error, you can suffer. Like an accident on the road. You can be very, very careful. But if an opposite person is careless, you're gone. Somebody else's fault, and you are suffering. Huh?
Please. I was telling him to be careful. He's
Why,
in
what
front
happened?
of me in the lab.
Give him one hard slap if you find him disturbing you and not concentrating. That you keep caution and strength to smash the face of the person who's misbehaving for your protection. You can't keep wearing a raincoat all the time in front of you. You can't wear a raincoat and you can't wear a plastic sheet. Okay? Follows? Like for example, in ICSE college, there was a Muslim girl and she came with a burqa. Full top to bottom, she's covered up. I don't even know who she is, whether she's a man or a girl. She was covered up. And I said, roll number so and so. And then she put up her hand, she didn't open her mouth. I said, take that good off, because it is hanging, you're bending over, and that thing is going to catch fire. You can't use it. No, I belong to the Muslim community. I said, of course I know, but why don't you take science? You should mind for art, for commerce, where you don't have to work in the laboratory. You are behaving so foolishly, and because of your carelessness, all 40 children in my laboratory can catch fire. And you know something? I'll run out of the laboratory first. I don't want to sacrifice my life because of your carelessness. Again, I told her that. I'm not going to drown with my ship. Okay, I love my life, and I've got 3 children at home who are waiting for their mother. Hey, I'll slap you. And a hard slap and you too. And you, I'll smash you. So therefore you have to remember very carefully, your carelessness can cause somebody else his life or an accident, and you will never be able to get rid of that guilt. That's what I'm saying. That's the suffer. That's the suffering. You will never be able to get rid of that guilt. Every time you see that person, every time that thought will come into you, you'll feel horrible. You'll feel miserable. Okay? So you have to be very careful about it. Now, first of all, you have to, we are now talking about hydrogen. How do we prepare hydrogen? Now, can anyone tell me how you can prepare hydrogen? A general way, how? Okay, fine.
Traces of water with the presence of valued sulfuric acid.
Electrolysis of water. Now, suppose in the laboratory we do not have any electrical equipment because voltmeter comes in physics. It is a chemistry, but in the laboratory we don't have voltmeter, but we have got only acids and metals. So, can you tell me how hydrogen gas is liberated with the help of an acid and a metal? Put it down. Can you tell me how?
Adding magnesium to HCl.
Why did you use HCl?
HCl because it's an acid, and the magnesium is not so exclusive, but it can displace hydrogen.
Can displace
Hydrogen
from?
from HCl.
Very good. My God. He's given me an answer. For the first time, I can tell you the answer. Now pay attention here. Now pay attention. I said why HCl. His answer. He who told it. He told it. Now pay attention. Take transparent. Take transparent tape and tape it on this boy's mouth. And tape it. Now pay attention. I said, what do you think? I said, why HCl? Yeah.
Now we can use H2SO4 also.
Why H2SO4?
Because it has hydrogen.
Because it has got hydrogen. All acids have got hydrogen. But all compounds containing hydrogen are not acid. I told you that in the beginning. So we are using HCl, correct? Now, why did we use magnesium? Why did we not use copper? Copper is also metal. I said metal and an acid. Now he said magnesium, and he's right. For the first time in his life, he's right. But I'm saying, why did you not use copper? Mouth shut and behave yourself. Ian, sit straight. Come on. No, not you, this girl. Think. Why Mg and not copper? Mg and not copper.
Because magnesium is more reactive.
What do you mean by that?
It's like upper in
Look at my hands.
Yeah.
This is above hydrogen and the copper is below hydrogen. So copper will not displace hydrogen from the acid. Okay? Now, when the
If you use
can you
calcium oxalate, one the hydrogen.
pardon me?
If you use calcium oxalate, one the hydrogen.
If you use what?
Calcium
Calcium is what? What will happen?
oxalate, one the hydrogen.
Burn. Why burn?
If you use potassium.
No, nothing will happen that way. Are you using Na? We don't use sodium and potassium because they're very highly reactive. And they are they can catch fire very easily. Correct? What he said is true. So we use lower reactive metals like calcium and magnesium and zinc and aluminium and so on. As you go lower and lower down, but they should be above hydrogen. Huh? Lead also you can use, but as you go low, pay attention. I'll smash you. Don't make me shout. Behave yourself, Ian. As you go lower and lower down in the reactivity series, you'll find the evolution taking place, but this evolution is given at a very low rate. But if it is magnesium, it is brisk. It is brisk. So the reactivity is lessening, but the metals have to be above hydrogen in the reactivity series. Now, same thing when you use H2SO4, correct? Both of them have got hydrogen in them. There's no need for you to use heat here, and there's no need for you to use concentrated acid. You can get the same results with dilute acid and less of heat. So you save a lot of fuel.
We don't heat.
There's no need. If you want to heat and be quick, fine, because you'll get only half an hour. Okay? And by the time you set up the apparatus and this, that, and the other, the experiment cannot be done. So we use heat, but actually there's no need for using heat. Now, second part of it. As the gas is being liberated, what will be the color of the pulmon? What's the color of the gas? Hydrogen? Tell me. Colorless. Okay. Then smell. Odorless. It's colorless, odorless. So you don't even know that the gas is being liberated because it's colorless and it is odorless, no smell. So you try to test it with litmus paper, moist litmus paper. You just place it in the gas and you will find that it is neutral. Okay, it's neutral. Now what happens is, how do you know? Then when we put it in the laboratory, it is supposed to be collected by the downward displacement of water. So that means it is insoluble in water and it is lighter than water. So it goes up and water comes down, correct? Yeah, why you had a hand now what happens is, here again, how do I know that the test tube is full? Or how do I know that the gas being liberated is hydrogen? Yeah. If you use a burning splinter, it will catch fire. It will burn with a blue flame, a popping sound. See, I is blue flame, popping sound, okay? And when you see, you'll find a collection of water there, correct? Also.
Pure hydrogen burns.
Huh?
Pure hydrogen burns.
Yeah. But that is also a very dangerous thing because hydrogen is an inflammable gas. So I would say we don't want to use the fire method.
Use a cathode.
What cathode is a test tube we've got?
Then anode and the hydrogen cover.
I told you we are not using voltmeter, we're not using electrolysis in the laboratory. We just take a rod. We take a rod and what we will do is wet it, moisten it, and you place that water a bit. Okay, don't take water. You take a rod and dip it in ammonia, NH3. You just make sure, and you take that and you hold it close to that H hydrogen that is coming out. Okay, follow. What's going to happen? Immediately you find dense white fumes coming out, and that shows that ammonium chloride is being liberated. Hydrogen coming in contact with that rod, ammonium hydroxide. Dip the rod in ammonium hydroxide. Ammonium hydroxide is a base, and ammonium hydroxide is a liquid. So just take a glass rod, dip it in ammonium hydroxide, which is absolutely non-dangerous, and just place it on the mouth of the test tube. You can see the fumes coming out. The fumes are coming out. You hold that test tube, you hold the rod here, and the fumes will touch that ammonium hydroxide and will give you dense white fumes of ammonium chloride. And the smell, you get this very strong smell of ammonium chloride. So that is
Ammonium chloride. It is dangerous.
Ammonium chloride, not at all. Not at all dangerous. In fact, ammonium chloride has got a very strong smell of ammonia. And when people faint, you just pass that ammonia under their nose with a strong urine smell, the person is revived. Then we can take the person to the doctor. Okay, because the person has to be revived, temporarily revived. Okay, now here.
H2S.
H2S is smelling rotten gas.
Very nice. Very good.
Yeah.
Yeah, it smells good, right? So good.
Now the next one, oxygen. How will we get oxygen? How do we get oxygen? Use metals and metal oxides. Use oxides. For oxygen, we have to use oxide. So you use metal oxides. Okay? For that matter, use oxidizing agents. Oxidizing agents give out oxygen. You can use lead oxide, Pb3O4 or PbO2. Okay? and you gently heat it, just heat it gently, what you're going to get is oxygen. How do you know that oxygen is being liberated? You just hold a glowing splinter, matchstick, you light it, put it off, one little part is glowing, you put it into that fumes that are coming out, it will burst into a flame. You'll find that the gas is not burning, but the stick is burning. It supports combustion, but it does not burn. Okay, that is your oxygen. All right. Pardon me, that is your oxygen. Again, it is a colorless gas, odorless gas, and it is neutral. Okay. Third one, carbon dioxide. Here you are. Keep your hands on your lap. Now, how will you identify or how will you produce carbon dioxide? Mouth check. Carbon dioxide. From where do you get carbon dioxide? Don't look in the book.
It's an end product of respiration.
No, that is a definitely can we keep on standing there and keep on. That is, I said, how do we manufacture it? Okay, not produce it. Producing it, you're producing it run but then we call preparation. Not produce it, but how do we prepare it? There's a difference between manufacture, there's a difference between preparation, there's a difference between producing. If you say producing it, it's a part of respiration. If you're talking about preparation, it's laboratory preparation. Okay? Manufacture is industrial, large scale. So how will you prepare carbon dioxide? Can anyone tell me how do you prepare carbon dioxide?
Heating of metal carbonate.
Metal carbonate or metal bicarbonates. Metal carbonates or metal bicarbonate. You heat them. You heat, all right, and you're getting what? The carbon dioxide. Suppose you're taking calcium carbonate, what?
It is sodium bicarbonate and sulfuric acid.
If you're using either if you're using an acid, suppose you're taking sodium carbonate and you're using an acid, what will you get? You will get if you're using sulfuric acid, you'll get the metal sulfate. You'll get water and carbon dioxide. But if you're using the plain metal carbonate, calcium carbonate, plain, no acid, nothing, and you're just heating it, you'll get metal oxide and carbon dioxide. If you're only using the carbonate, metal carbonate, you will get the metal oxide and you'll get the carbon dioxide. But if you're using the acid, calcium carbonate with the acid, then you are going to get calcium chloride, depending upon which acid you're using. If you're using HCl, you'll get calcium chloride. Then you're going to get water and you're going to get carbon dioxide. Either way, plainly heating or you are going to, or with the presence of an acid. If you're just plainly heating it, what type of a reaction is that called? This boy, if you just take calcium carbonate and heat it, what type of a reaction is it? Say, correct. Loudly. Why endothermic? Why do you say endothermic? Why not exothermic? Because they're giving it heat. Because they're supplying it heat. I give them a good high, big clap. Give them a big clap.
He said wrong answer.
Yeah, he said it releases energy. He said it releases energy.
No, endothermic means they're giving it energy. Endo means in, giving it in the experiment. Okay, and exo means exude, exit, leaving. That's how it is found. That's how you remember. Now, how will you? How will you identify that gas? How will you identify the carbon dioxide which is being liberated? Again, it is colorless, it is odorless. You can't taste it, we won't say tasteless. Yeah, how will we identify it?
When it is passed through a solution of lime water, it turns it milky.
Directly when it passes through lime water, this solution of lime water, when it passes through lime water, you get a white PPK. That is called milk of lime, calcium carbonate. Correct, Brian?
And also, if we bring a burning splinter or a matchstick, it gets mixed.
It puts up. The carbon dioxide is. I told you, I explained you how fires put up by carbon dioxide. Yes or no?
So,
yeah.
but for lime water, even if we run sulfur dioxide through lime water, it will turn milky.
Yes.
So we should take a moist blue litmus paper to turn.
It is done right. Sulfur dioxide also is acidic.
Yeah.
It's very similar. Both those gases are very, very similar. Only thing is, in the case of sulfur dioxide, you get the smell of sulfur. In the case of carbon dioxide, what happens?
When you breathe it, you start coughing. Carbon dioxide.
It has more effect on potassium dichromate and potassium.
Now those big things we don't want, cut out. Cut out those, it's not necessary. It's not at all necessary. Carbon dioxide does not support combustion, it does not burn, and when passed through lime, water, and calcium hydroxide, it gives you a white PPT, milky solution because calcium carbonate is formed. Now, if you take the calcium carbonate and we take water and we pass more carbon dioxide to it, we're getting calcium bicarbonate. When calcium bicarbonate is formed, you find all the milkiness disappearing because calcium bicarbonate is soluble in water. Is soluble in water. Okay, so that is your identifier of. That's how you get your hard water. I think hard water is cancelled out. Is cancelled in your.
Yeah, in the first.
It's in the second.
Yeah, it's in the second term.
What?
Hard water and soft water.
In the second semester. Okay. Now,
We have got
how do we get hydrogen chloride? You put your hand up for what?
Ma'am, we have that. What is it? Water test.
Water.
Test.
What test? What for water you did? What test you did for water?
That crystallization.
Crystallization. That water crystallization. That's something different. I will come to that later on. That is the presence of water vapor in the atmosphere. Now we come to how will you prepare or how will you get hydrochloric acid. Now simple. You will take either sodium chloride or potassium chloride. Okay, not sodium but sodium chloride and potassium chloride. Correct?
Preparation of gases is not in our syllabus.
Which preparation of
Gases.
this practical work is nothing other than
No, like just the
Preparation
preparation.
is not.
Like these things are not in our syllabus.
this is not preparation, it's recognition.
No, yes, like recognition is
Yeah,
distinct
yeah.
part.
No, but
Atika.
Preeti ma'am said you have to do it if you don't prepare.
If you don't remember, how will you recognize it?
I can't.
No, but this is, pay attention, this is there, these equations are there in your book, inside your book. All the practical lesson I'm teaching you today is actually a summation of all the reactions which are there in the chapter. Okay, followed? Now, so therefore what will happen, how do you get your hydrogen chloride? For hydrogen chloride, what will you take? You are taking sodium chloride or you're taking potassium chloride. Okay, and then you're adding what to that? Sulfuric acid. At room temperature, initially you're getting the liberation of hydrogen. How did hydrogen chloride? How do you know the hydrogen chloride that is coming out? Again, you dip a rod of a rod with ammonia or ammonium hydroxide. Again, place it in the mouth, dense white fumes of ammonium chloride. Is this clear? All of you have. How do you know that that gas is hydrogen chloride? Because it is acidic in nature. It is soluble in water. HCl is slightly soluble in water, so it's not collected by the downward displacement of water. How happens?
Ma'am, when it is passed through silver nitrate solution, it
Yeah,
forms
when you
a
pass
milky
it,
white
it's
precipitate.
AgCl. You get a white PPT of
Silver,
AgCl. Silver chloride. Silver chloride. And then you pass more through it. Okay? Silver chloride, but you add ammonium hydroxide to silver chloride, you're going to get the white PPT gone. So soluble completely. Now till there, what about sulfur dioxide? How do you identify? How will you get sulfur dioxide? Take any
burning sulfur,
hydrochloric acid with any sulfate, sodium sulfate. Take sodium sulfate and hydrogen chloride. Take a metal sulfate which is above hydrogen in the reactivity series. Take a metal sulfate above hydrogen in the reactivity, so sodium sulfate, Na2SO4 plus HCl. So getting NaCl, you get water and sulfur dioxide. How do you know it's sulfur dioxide? From the
burning
smell.
smell of sulfur.
Sulfur, and also when you pass it through live water,
It
you're
turns
going to
milky.
get calcium sulfide, which is actually nothing else but a white PPT And then when you add more sulfur dioxide to it, more water, it will get calcium by sulfite, which is soluble in water. This is clear? So this is the way you do it. Now make this hydrogen sulfide. Hydrogen sulfide, zinc sulfide. Take zinc sulfide, any sulfide, metal sulfide with HCl. With HCl, we are going to get zinc chloride plus hydrogen sulfide. How do you know the sulfide?
Colorless, rotten
Yeah,
exterior.
and you are actually getting what? Rotten smell. But when this gas is passed through water, you get a turbidity. You get a milky type of a solution. That is your H2S gas. Horrible, rotten smell. Okay, yeah. Now, about ammonia. How will you get ammonia?
Ma'am,
Take
it,
any,
It has a unique like identification, moist red litmus tube,
which one?
ammonia.
Yeah, but first of all, how do you produce it? You take any ammonium salt, any ammonium salt, ammonium chloride, ammonium carbonate, ammonium sulfide, ammonium sulfate, and you add an acid to it, immediately you get the gas ammonia liberated. How do you know that? Because it will turn red litmus paper blue.
Moist red litmus.
Yeah, moist litmus paper, and it has got a very strong urine smell. This is now, when you add it to, when you pass any ammonium chloride solution through Nestler's reagent, Nestler's reagent, which is colorless, becomes brown in color.
When we take a glass rod dipped in chlorine, it produces white, dense white.
That is hydrochloric acid.
Chlorine,
Hydrochloric acid. Hydrochloric acid. Ammonia with hydrochloric is ammonium chloride. Ammonia, when you dip a rod of HCl, dip an HCl rod, okay, in the NH3, NH3 plus HCl, NH3 plus HCl, with the NH4Cl, this addition. Now, water vapor. Water vapor is again obtained from compounds containing water of crystallization. Take copper sulfate or take sodium carbonate plus 10H2O. Okay, gently, don't, if it is Na2CO3, sodium carbonate, yeah, plus the 10H2O, you just keep it on the table and it will give out its own water. That's called efflorescence. Okay, that is water crystallization. But if you take copper sulfate, you have to 5H2O, gently release it. You find that the blue color has disappeared. You find on the colder part of the test tube, got water crystallization, and the blue powder has become white. Yeah, blue crystal become white.
and COCl2 cobalt chloride favored as pink.
Pinkish in color, copper chloride. That is copper chloride. Cobalt chloride. Cobalt.
COCl2.
COCl2, that is cobalt chloride. Pinkish in color. Okay, fine. Nitrogen dioxide. How will you get nitrogen dioxide? I will take any nitrate salt. Any nitrate, sodium nitrate. Again, add acid to it. You are getting brown fumes.
Nitrogen dioxide.
Yeah, like nitrogen dioxide. Okay. Till there you read to it. Then till there you read, and then you go to the page 140 where they have given you the gas, the color, the odor, and the nature. Read all that till there you read. Then I will do action of heat on giving certain substances. Come on.
Chlorine.
Okay, sorry, chlorine. How will you get chlorine? Chlorine actually is a
Greenish
greenish
yellow
yellow gas. Okay, you take what? You take,
Concentrated HCl and pass it to oxidizing it.
yeah, you take H2SO4 concentrated and MnO2. MnO2 is a black powder. It's a black powder. So when you put, first of all, you put HCl, H2SO4, and then you have to put the black powder. When you put the black powder, you must make sure that the black powder doesn't touch the inside walls of the test tube, because if the inside walls of the test tube are coated with black powder, you will not be able to see the evolution of the gas. Correct? You will not be able to, and you have poured acid into the inside the test tube, so the test tube inner walls are already moist because the acid has touched it. So very carefully, what we do is we put the acid in the test tube, okay, and then what we do is we take the powder. It's like charcoal powder. MnO2 is a strongly oxidizing agent. Now what we do is we take it, and we don't take not H2SO4, we take HCl, because chlorine has been given out. So HCl we take, and then you are taking H2SO4 also, because H2SO4 helps the reaction to take place very, very fast. Then we add MnO2, but we put it into the fold of a paper. Okay, in the book, because if you put only like this,
Oh, like
it will get
shape,
yeah. So we put into the roll of a paper and gently put the roll and let's make sure that it gets inside the acid, not on the inner walls of the test tube. Gently you heat it. When you heat it very, very gently, what you'll see greenish yellow gas with a very pungent odor being is escaping. Now, in that gas, you have to be very careful because you're dealing with a lot of two concentrated gases, HCl and H2SO4, correct? And then you take moist blue litmus paper, and put in the fumes. The blue, where the fumes are touching that blue litmus paper, it will turn red and then get bleached. And it will become white because chlorine is a very strong bleaching agent. That is why we put it into our swimming pools. When you are swimming, you put a lot of chlorine into it because it kills all the germs. Okay, and when you come out of the swimming pool, you have your skin very, very brown and dark, and sometimes your hair also gets very bleached. So you have to put a cap, and you always have to apply eucalyptus oil on your body. Not, eucalyptus oil is okay. It protects your skin from the direct contact of chlorine water. Okay. Now, till there we read, and we read also the page 140. Learn those equations. Every equation is to be written down. Yeah, two times, please. Please go. Come on, read. Write down the equation. Don't tell me you've done it. If you've done it, get it from me and go to the exam sentence down there. Have all of you understood this chapter 10.2 just now? Next class will be the last class. So tomorrow, what shall we do in English?
The right way.
The
Right way.
okay, fine. We'll do the night.
No.
Night.
I can ask.
Not for both, like 2 hours.
Two hours, yeah. One is for question, poetic is question answer. Will you please concentrate on your chemistry right now? And you? Right. The equations are very important. Read first and then write. Put it up. Put up the fan. This metal fan, put it up. Ian, put the metal fan off. Come on, hurry up. Your second brother is how old is boy? What? Your second brother, you have another brother, no? How old is he?
9.
Huh? 9 years. मतलब the second standard, third standard, fourth standard. Come on. stop talking and start writing your work. Read and write. I don't want you to talk. I've given you time in the classroom to do your work. Keep a book on the table and write. Or on the lap. What do you want?
What if you have the lab?
You want to this thing, you can take this book. And the lal is not there.
Last.
What about this thing? What about UT volume is not there, UT volume?
No, chapter is omitted in YouTube.
Okay.
If gas is released from factories and taken back,
That is your this thing, carbon dioxide. Carbon dioxide. No, sorry, not carbon monoxide. Carbon monoxide is soot and carbon monoxide.
it's carbon dioxide. Why is carbon monoxide there?
Because it's got unburned carbon particles in it. And when all the carbon particles are completely burned, then you get carbon dioxide. Carbon dioxide is completely burning, complete combustion. Like in your stove, in your cooking, the black vessels, the residue become black because it's completely burned. It's carbon dioxide. But if it is suppose milk has fallen in your burner, then the smoke is blacky. That means unburned carbon in partial oxidation. So the fuel is not burning completely; it's burning halfway. So you're getting unburned carbon particles just sticking to the walls of the vessels. Shh. Like traffic.
What's special about blue litmus paper?
Huh?
What's special about blue litmus paper?
Blue litmus paper is paper dipped in blue, is filter paper dipped in blue litmus. And red litmus paper is filter paper dipped in red litmus. And the dry nothing to switch, nothing to switch.
How do we make red?
Litmus is a solution.
How do we make red? Please explain.
Pay attention. How do you make red litmus paper? First of all, litmus. Pay attention.
It's obtained from leaching.
From
Leaching.
yeah. Actually, litmus is obtained from these tiny little plants that grow by the riverside. Now see, if you have gone to the village, if you have gone to the village, and if you have gone and looked inside a well, how many of you have gone and looked inside a well? Well, at the side, as the water in the month of May, as the level of water in the well recedes, on the sides of the well, you find small little plants, no? Moss and those are called lichens. Those are called lichens, so those are called these plants. Okay. Now, if you take all of them, okay, such a huge amount, and you liquidize it and squeeze it, what you get is colorless litmus solution. Colorless litmus solution. Very expensive because you're using such of those plants and you're getting only this much of solution. Okay? Now that solution is litmus solution, but it is colorless. Now what I will do is I will keep that as a stock and take little of it and keep in one test tube, in one beaker. Take little of it, even another beaker. This I will keep for further use. And in this beaker, I will pour base. It becomes blue litmus. In this, I will pour acid. It will become red litmus. Now, I've got solutions. I can't give those solutions to you because if I ask you to use only one drop, you may use the whole lot. And maybe the glass will fall down from your hand and the solution can get wasted and expensive. So therefore, I would feel it is safer for you to use paper instead of glass apparatus. So you have got filter paper, you just dip it into blue litmus, dry it up, red litmus, dry it up. Filter paper. Then you cut into strips, like red litmus paper, blue litmus paper. Use it. That's all. The litmus is actually natural. It's coming from lichens. It is very expensive. Okay? It is colorless and it is neutral.
It's not to like
It is
this.
colorless and neutral. It's only when we add base, it becomes basic and blue. If we add acid, it becomes acidic and red. What?
So how do like it, sir?
How do?
Like it, sir.
They're growing. Suppose you walk on the road, you find a little plants growing out. They all like it.
How you see?
They grow. Yes, there are seeds. Of course, definitely there are seeds. Everything has to come out from seeds. No?
They come from spores.
Spores are what? Part of seeds only. When the plant bursts, when the flower bursts, it gives out the spores, the pollen grains, the spores that gets pollinated.
So it comes from this plant.
Huh?
Comes from this plant.
Comes from ordinary grass. Ordinary, very nothing special about it. Moss and
In
grass.
the old photos, they put in some
Huh?
old photos, they put the old photos in.
That is silver nitrate solution for developing of the photo. That is different. Hey, what are you doing? The book is closed. Yes, sir. So what about your okay, so what your identity equations? No?
I'm reading.
Reading, how you are reading when your eyes are there on the wall and the book is wide open and what you're reading like this.
No, I was reading.
Focus on that page. You're looking at me and said, you never seen me in your life. Huh? a silly question you written down in. Okay, you can go now. Ran! Now too late, finish.
Touching without consent.
Why do you say that all the time?
क्या अरे मैंने कब बोला ये बोला
मैंने कुछ बोला ही नहीं.
मैंने नहीं बोला
I'm annoying at this point. Very
फर्स्ट स्टेप्स अरे छोड़